Welcome to today's video. I'm going to show you how we can solve basic logarithm questions, Form 3 mathematics. And we'll begin with this question here, where we have logarithm of 32 raised to 2 over 5 to base 8 is equivalent to x. So what we do, we can remove this by finding the fifth root of 32 and squaring it. So this is the same as logarithm of 2 raised to 2 to base 8 is equals to x. This is because the fifth root of 32 is 2. Fifth root means that the number that you multiply 5 times to get 32, and that is 2. This is equivalent to logarithm of 4 to base 8 is equals to x. To solve this, you can put it in exponential form. This is the same as 8 raised to x is equals to 4. You can simplify this by having 2 raised to 3, because 2 raised to 3 is actually 8. X is equals to 2 raised to 2. And from this expression, you can see that 3x is equals to 2. Therefore, 3x is equals to 2. X is equals to 2 over 3. X equals to 2 over 3. That is how you solve this question. We can look at this other question here. Logarithm of x is equals to logarithm of 5 minus logarithm of 2x plus 3. An assumption here is that all these logs are to base 10. Therefore, you can have logarithm of x is equals to logarithm of 5 divided by 2x plus 3. This is because logarithm of a over b to base 10 is equals to logarithm of a minus logarithm of b to base 10. As long as the base are the same, then logarithm of a over b to base 10 is equivalent to logarithm of a minus logarithm of b. So you can be able to put this in this format here. And this, since these logs are the same, you can actually say that x equals to 5 over 2x plus 3. We can solve this. You can say this is x into 2x plus 3 by multiplying by 2x plus 3 multiplied by 2x plus 3. You can cancel this. This is equivalent to 5. So if you open the bracket, you can have 2x squared plus 3x is equals to 5. This is a quadratic equation of the form 2x squared plus 3x minus 5 is equals to 0. And if you remember the quadratic equations, these are the same as this is just in the same format as ax squared plus bx plus c is equals to 0. And we know that we can solve this either by completing the square or by using the formula. Let's use the formula. The formula for this is x equals to negative b plus or minus square root of b squared minus 4ac divided by 2a. A in our equation is 2, b is 3, c is negative 5. So we can replace b by negative 3 plus or minus. You can see that it has two solutions. Square root of b squared, b is 3, so 3 squared, minus 4 multiplied by a, which in this case is 2, multiplied by c, which is negative 5. All divided by 2 multiplied by a, which is 2. So this gives us negative 3 plus or minus square root of 9 plus, because of the two negatives, negative and negative becomes positive. 4 by 2 is 8, by 5 is 40, divided by 4. So this is negative 3 plus or minus square root of 49 divided by 4. So this is either negative 3 plus 7 over 4, or negative 3, negative 7 over 4. So this is 4 over 4, which is equals to 1, and this other one is negative 10 over 4, which is negative 5 over 2. So this equation has two answers, 1 and 5 over 2. If you want to prove that x is 1, you can replace. Let's replace here. You can have logarithm of 1 is equals to logarithm of 5 minus logarithm of 2 plus 3, which is 5. So logarithm of 1 is equals to logarithm of 5 minus logarithm of 5. And this is the same as logarithm of 1 is equals to logarithm of 5 over 5, which means that 1 is equals to 5 over 5, which is equals to 1. So we can be able to prove that. That is how you solve that equation. We can still look at the last one for today. And this one is logarithm of 1 over y to base 5 is equals to negative 3. So logarithm of 1 over y to base 5 is equals to negative 3. If we put this in exponential form, this is the same as 5 raised to negative 3 is equals to 1 over y. And this negative here, you can actually bring it down. 5 raised to 3 is equals to 1 over y. And therefore y is equals to 5 over 3 is equals to 125. You can prove that. You can prove by having logarithm of 1 over 125 to base 5 and see whether we can get negative 3. So this is the same as logarithm of 1 over 5 raised to 3 to base 5. This is equivalent to logarithm of 5 raised to negative 3 raised to 5. And this is the same as negative 3 logarithm of 5 to base 5, which gives you negative 3 times 1, which is negative 3. So the reason we are doing this is because of the rule that logarithm of a raised to n to base b is equivalent to n logarithm of a to base b. So that's why we are doing that. So thank you for watching. Next time we'll look at more examples.